video discusses the difference in means for two independent samples. Researchers asked the question, to what extent have changes in science and technology changed the way you do your job? The response was measured on a 7-point scale, 1 low to 7 high. Responses are summarized as: for forensic professionals, the sample mean is 5.67. The sample variance is 1.37 and the sample size is 30. For police officers, the sample mean is 4.36. The sample variance is 3.72 and the sample size is 27. We make the following assumptions for our data. The two samples we take are independent. Data is approximately bell-shaped, and the variability for both groups is the same. That is, sigma 1 is equal to sigma 2, which we will call sigma. The 5 steps we follow are: Step 1, the null hypothesis is that the two population means are equal. The alternate hypothesis is that the two means are different. We use a two-sided alternate hypothesis as we are just looking for a difference. We need to estimate the common variance term sigma squared. So we use the pooled variance using the information in both samples. The pooled variance is a weighted average of the two sample variances. We weight by the degrees of freedom. If we have more observations from one group, then the sample variance gets a higher weighting. The variance of one sample mean x bar is the population variance over the sample size. When we take the difference of two independent means, then we just sum their variances. We then take the square root to get the standard error of the difference in two sample means. That is, we get the square root of SP squared over n1 plus SP squared over n2. The SP squared is common, so we write this as the square root of SP squared times 1 over n1 plus 1 over n2. If we increase the sample size for one group, the standard error decreases. But it will only affect one part of the standard error. Ideally, you want both n1 and n2 large. We can put everything together and do all the calculations at once. The formula is exactly the same, and all we need to do is plug in the numbers from our summary statistics of the data. As we pool the sample variances, we just add the 2 degrees of freedom. So the degrees of freedom we use are n1 minus 1 plus n2 minus 1, or n1 plus n2 minus 2 degrees of freedom. Step 2. Sampling distribution and critical values. We use the t-distribution with n1 plus n2 minus 2, or 30 plus 27 minus 2, which is 55 degrees of freedom. For 55 degrees of freedom, the critical value with 0.025 in the right tail is t.025, which is 2.004. So we reject the null hypothesis if the absolute value of t is greater than 2.004. The critical values are illustrated in the picture of the t-distribution on 55 degrees of freedom. We substitute the values into the standard error formula. The sample sizes are 30 and 27. The sample variances are 1.37 and 3.72. The standard error is then calculated to be 0.42. The difference in the sample means is 5.67 minus 4.36, or 1.31. We cannot tell if this is a significant difference, so we normalize it by the standard error and compare it to the table values. Dividing the difference in means by its standard error gives us 1.31 divided by 0.42. The t-statistic is then 3.12. The value of 3.12 is greater than 2.004 and is therefore in the rejection region. We reject the null hypothesis and conclude that there is a significant difference between forensic professionals and police officers with respect to the effect of technology on their jobs. A 95% confidence interval for the difference in means between the two groups is given by all values of the difference in means that would be accepted. The formula in this case is given by the point estimator plus or minus the critical t-value from the table times the standard error. The difference in two means is 5.67 minus 4.36, which is 1.31. The standard error is 0.42. The critical value is 2.004. Hence we are 95% sure the difference in the two means is in the interval 1.31 plus or minus 2.004 times 0.42, or 1.31 plus or minus 0.84. We write this as 0.47 to 2.15. Note that 0 is not in the interval, as we rejected it. Thank you for watching. In the next video tutorial, we cover analysis of variance.